Hey, good morning, everyone. I hope you have been having just as enjoyable of a week here at Q2B as I have. Thank you for joining me today. My name is Amy Golem, and I am the Senior Regional Sales Manager for North America at Pasqal. For those who aren't aware, Pasqal is a full stack neutral atom based quantum computing company headquartered outside of Paris, France. But as mentioned, I look forward today to talking to you a bit about our company and technology, as well as about our expansion into North America. So, digging deeper into our agenda for today, we will, like I said, start off with an introduction about Pasqal as a company, as well as our neutral atom based technology. And then I'll talk a little bit about some recent use case results in drug discovery, as well as our recent sustainability focused hackathon. And finally, I'll close us out with some exciting information about our North America expansion, as well as ways to collaborate with us. Pasqal, as I mentioned, is based right outside of Paris, France, and we were founded in 2019. Our co-founders are a fabulous group of very well-renowned physicists, one of which was the 2022 winner of the Nobel Prize, Professor Alain Aspect. And we also have our scientific lead, Professor Antoine Borois, and our wonderful CEO, Georges-Olivier Raymond. Today, we have a 100-qubit system available, our Fresnel device, and we have over 200 scientists and engineers hard at work in the labs. We're proud that we have raised over $140 million in funding thus far, and we have over 200 scientific publications today, looking to double that number in the coming year. Let's talk a little bit more about Pasqal's technology. As I mentioned, we are a full stack platform based on neutral atoms. So starting from the top of the stack with software and applications. We have Pulsar, which is our open source software, in addition to Pulsar Studio, which is an open access graphical user interface that allows users to more inherently and easily understand how to work with our technology. I'd also like to mention our quantum discovery platform. This is an e-learning platform that provides users with the ability to understand the fundamentals of quantum computing, then understand how neutral atom quantum computing works and differs from other quantum modalities, as well as understanding Pasqal's specific technology and how to use our software and hardware. Finally, we have these turnkey solutions. These are pre-coded algorithms with complex logic that are dedicated to the hardware-specific quantum libraries that are located in our middleware, which is a great segue to talk about our middleware. These hardware-accelerated quantum libraries are specifically optimized for our Pasqal neutral atom devices, and they are in 4 primary areas: optimization, simulation, differential equations, and machine learning. Now, I'll talk about this in a moment, but the software and middleware layers are particularly one of our differentiators in the sense that we work very closely with our customers on focusing on real-world implementation at scale today. So, as the previous slide showed in the title, yes, we have over 40 years of scientific backing. We have a very strong science and academic research mindset. However, we are also very focused on business relevance and bringing solutions to the market today, particularly by leveraging the dual analog and digital nature of our neutral atom devices. Okay, so let's talk a bit about the hardware. From a quantum register perspective, I mentioned that we have 100 qubits available today. Really, we're operating in the 100 to 200 qubit range, but those 100 qubits are addressable now. I would be on the lookout, if I were you, for 2024, where we will be coming out with an announcement for our 1000 atom device and what that means for the future. You might hear us talk about how our QPU works at room temperature and in a standard environment. So what we mean by that is we do not have the necessity for refrigerators or dilution refrigerators like other hardware modalities might. What that does is it helps us be able to operate these in a standard environment like in a data center, but it also helps us consume less energy, around 5 kilowatts. Our electronics controls are very important for our systems as they need to be incredibly quick. They control the lasers that in turn manipulate the atoms in our devices. So we are starting to develop some of that electronics control in-house as well. Speaking of in-house, I'm excited to say that our ultra-high vacuum is based on our in-house expertise. We were working very closely with a really great ultra-high vacuum company that we ended up acquiring. So that expertise is in-house, and it's a very important component that houses the atoms, in turn our qubits for our devices. And then finally, the laser control. So laser control is what cools down our atoms as well as manipulates them, encodes information, etc. We work very closely in collaboration with our laser control providers, and we are starting to also see some improvements in the supply chain for those of you who've been keeping an eye on this the past couple years. So this full stack software, middleware, and hardware is all dedicated, like I said earlier, to support our end users and customers. We work with a number of customers across industries on developing and implementing those real-world use cases at scale, like I mentioned, across industries like automotive, energy, finance, and more. I'd also like to mention that we do on-premise installations for those who are interested in having our neutral atoms devices closer to home. So the two that we are delivering in the near term are in Germany at Jülich and in France at Gen C. Okay, so we've talked a little bit about Pasqal as a company, a little bit about Pasqal's technology. Now I would like to talk a bit about our recent results, particularly in drug discovery. So in collaboration with Qubit Pharmaceuticals recently, we tackled a critical molecular biology problem in the drug discovery process. To give you a bit of context as to the problem that we're talking about, we have a protein, and this protein is toxic or faulty in the body, which in turn causes sickness, illness, or disease. Researchers then in drug discovery, they use ligands, which is a small, simple molecule, to attach to and inhibit this toxic protein. Now, one of the challenges with this process in drug discovery is that researchers must be looking at the protein-ligand interaction in a realistic environment. One of the core pieces of a realistic environment for this is the presence of water molecules. Understanding where water molecules are placed is a very challenging process, particularly for today's computational methods as well as some experimental methods. So enter our hybrid quantum classical algorithm that we developed with Qubit Pharmaceuticals. This starts with a method using density functional theory to outline where the distribution of these water molecules is to give us an estimate of the location. And then we use our quantum algorithm developed by Pasqal based on binary optimization to discretize this density map. We assign qubits to each of the elements representing where a water molecule is placed. And then from there, our goal is to run this through our Fresnel machine on the cloud and find a bit string that then represents the water distribution and location. Our goal with finding that is to then re-put together that density map that we saw from the DFT calculation and then compare the two. So once we get the results from our Fresnel device, we then look at that density map, compare it to the original DFT calculations. And once the two of those are similar enough or they have few enough differences, we can then feel comfortable and confident that we understand the distribution of these water molecules in a protein cavity. Again, the goal of that is to help us more accurately study the protein and ligand interaction that is necessary and a crucial step in drug discovery. So this is very exciting. We're very pleased to be presenting about this today. It is one small step in a long and arduous process for drug discovery. However, it is a very exciting and promising step for quantum computing, specifically with our neutral atom devices, for the promise and potential of real-world applications. Another highlight that I'd like to mention today is our recent Blaise Pascal Regenerative Quantum Challenge. This hackathon, our inaugural hackathon, was focused on sustainability. And by that, we mean it was looking at sustainability-focused use cases, in addition to assessing the sustainability benefits of our neutral atom devices. This attracted over 800 candidates and 75 proposals globally from over 25 countries. I'm very, very pleased to announce, we have announced it, but to re-announce the 2023 winning projects, the first prize of which was around renewable energy forecasting. I'd also like to mention, please be on the lookout in 2024, where we are excited to build upon the great community we started with this hackathon, and we'll be coming out with more information about a Pasqal community that we're continuing to grow. Okay, so we talked about Pasqal, we talked about our technology, and then some recent use cases and results. I'd now like to focus on our expansion into North America. We have a manufacturing facility that we're developing in Sherbrooke, Quebec, up in Canada. In addition, we are expanding our North America partner ecosystem. So that is across Canada and the US, with the goal of bringing the incredible results, ecosystem, and partnerships that we have in Europe, as well as the Middle East and Asia, over to the US and Canada as well. If you're interested in understanding what that type of partnership and joining this ecosystem looks like, please reach out to me or come to our booth later today. In addition to this expansion on the ecosystem in our manufacturing facility, we are also expanding our team. So we are hiring a multifaceted team both in the US and Canada. The Canada team has already been large and growing over the past year, and be on the lookout for more information about how we're growing our team in the US in 2024. Finally, all of this is also to contribute to the growing US commercial development efforts that are underway, which is a perfect segue into how to collaborate with us. So Pasqal has a quantum adoption plan that is designed to meet you where you are along your quantum journey, as well as exploring the benefits of neutral atom quantum computing and our proprietary algorithms that can help you with those real-world implementations. If you're on the earlier stage of quantum, either quantum computing in general or neutral atoms as a technology, I recommend the quantum discovery platform that I mentioned earlier. So this quantum discovery platform, as I said, has various e-learning modules from the fundamentals up to the details of Pascal's Fresnel device, in addition to Jupyter notebooks that are available for your use, and use case evaluation and guided support from our research experts. We also provide to our customers using quantum discovery cloud-based QPU options and access to our emulators. Once you have quantum discovery under your belt, or you're starting off a little bit deeper into the process and ready to go into the R&D phase with Pasqal quantum computing, I recommend looking at two of our offerings, Proof of Concept and Quantum Solution, both of which are leveraging those turnkey solutions and quantum libraries that I mentioned earlier in the technology stack. And we work directly with our customers on identifying what's the use case of most interest and implementability in the near term for you, and then developing that with quantum code with our expert teams and helping you with the roadmap to your quantum advantage in that use case as well as others. And then finally, looking at how we industrialize. So if you are aware of neutral atom computers, you want to test Pasqal, you have a large team, we offer quantum as a service where we have cloud-based access to our QPU through our own Pasqal cloud, as well as be on the lookout for, in the next year, all of the other large cloud-based providers will have available. Additionally, quantum infrastructure services. So I mentioned that we're delivering to Gen Z and Jülich, our on-prem devices. If that is also something that interests you in the US or Canada, please come find me at the booth or reach out to me after, and that's something that we would be happy to discuss. So with that, I would like to thank you all so much for your time today. Please feel free to visit our website. We have a lot, especially on the Learning tab, of blogs, media posts, and information going deeper into our algorithms, deeper into our client use cases. Follow us on LinkedIn for our major announcements that we post frequently. And then, to my points earlier, if you're interested in discovering how we can work together, please feel free to connect with me on LinkedIn. With that, thank you, and hopefully I have some time for questions. I'm not sure. Thanks all. Well, thank you. Please come stop by our booth. We're doing VR demos as well so that you can see the quantum computer up close. Cheers. Have a great week.